Hey guys, welcome to my video on solving equations using properties of exponents. So in this video, I'm going to show you how to solve exponential equations. So if we're talking about an exponential equation, it means that the exponent itself is what you do not know. It's the unknown variable. So for example, if you had 3 as a base and then raised to the power of x squared, you notice that x squared is the exponent. So that's what we talk about with exponential equations. So 3 to the power of x squared is equal to 9, and that's what we want to solve. So you can only solve exponential equations, at least what you know now, right? So you can solve exponential equations if the bases are the same, okay? Because once the bases are the same, then you can set the exponents equal to each other. So if you notice here on my second step, the base I have, so the number that I have changed so that they have the same base is 9, because 9 can be changed into 3 squared. Once they have the same bases, what you can do here is set the exponents equal to each other. So x squared is equal to 2, and that's what you want to solve. So if x squared is equal to 2, then we take the square root of both sides to solve for x. Okay, so that's at a simple um, exponential equation. All right, make sure that they have the same exact base, and then you can set the exponents equal to each other. Okay, let's take a look at a different example. So here we have 9 to the power of x squared is equal to 3. So again, what I'm going to do is change 9 so that it has a base of 3, and 9 is equivalent to 3 squared. I'm not going to touch the exponent of x squared, and that's equal to 3 to the power of 1. Okay. This is going to be helpful that you're going to, putting this power of 1 here is going to be helpful because you're going to need to know what to set it equal to. So here we have 3 to the power of 2, which is equivalent to 9, and now it's being raised to the x squared, right? So you can use the properties of exponent to know that if a power is being raised to another power, then we multiply those powers. So technically this is 3 to the power of 2x squared is equal to base 3 to the power of 1. So again, they have the same bases. Now I'm going to take my exponents and I'm going to make them equal to each other. So we have 2x squared equals 1, and that's what I want to solve for, right? So again, we have 2x squared is equal to 1. Okay, don't take the square root first because you have to get rid of this 2. So we're going to divide by 2 first. And then we have x squared equals 1/2. But remember, you want to solve for x. So now, if x squared is equal to 1/2, then we take the square root of both sides. And now we have x equals positive and negative square root of 1/2. And then you could leave it this way, okay, for now. But if you'd like to simplify that, that's the square root of 1 over square root of 2. Then rationalize it, and that becomes square root of 2 over 2. Okay, that's your simplified answer. Okay, let's move on to the next example. Here we have 2 times x squared, 2 to the power of x squared times 4 to the power of x is equal to 1/2. We have 1, 2, 3 different bases here, right? So here the base is 2, here the base is 4, and then here the base is 1/2. Okay, so the best base I can think of and that you should think of is that every single one should have a base of 2 because that's much easier. Why? Because 4 can be changed into 2 to the power of 2. 1/2 can be changed into 2 to the power of negative 1. Okay, because remember, recall what that negative 1 or negative power does. It turns it into its reciprocal. So that's where I get it from. Okay, so now that we know that, we're going to bring everything else down. We have 2 to the power of x squared times 2 to the power of 2 to the power of x, and it's equal to 2 base 2 to the power of negative 1. Okay. Now you still can't set this equal to this because you have these two that needs to be combined. Using the properties of exponents, we know this becomes 2 to the power of 2x and we know that this stays the same. We also know that if something is being multiplied together with the same basis, we add the exponents together. So what we will do here is we will add the exponents x squared and 2x. Since they are not like terms, then they just become x squared plus 2x. Okay, now on the other side, I can't do much with the other side because that's just raised to negative 1 power. So if on the other side the exponent is negative 1, then x squared plus 2x is equal to negative 1. Now you have to recall how to solve quadratic equations. So remember, quadratic equations can be solved by using quadratic formula, they can be solved by using factoring, and they can be solved by using the completing the square. At this point, I could complete the square, but I'm going to show you factoring because that seems to be much easier for some of you. Okay, so what I'm going to do first is add 1 to both sides so that my equation is equal to 0. So I'm going to choose factoring as a method. Not everything is factorable, but at this point I do know this specific quadratic is factorable. So if you'd like to use the quadratic formula first, you can as well. So I'm going to use my X puzzle. I'm going to place 1 at the top and then 2 at the bottom. And I'm going to think of factors of 1, then when I add them is equal to 2. And this is why I said this was easy, because the numbers that will complete that puzzle is 1 and 1. So this becomes x plus 1 times x plus 1, which is equal to 0. And now my x's for both of them is equal to negative 1. All right, so that is my answer to this problem. All right, so that means this x was negative 1, and that means this x is negative 1. Okay, and together, if I check that, that should equal 1/2. Okay, let's take a look at a different example. Here we have 16 to the power of x squared divided by 4 to the power of x is equal to 2. So much like the previous problem, not all of my bases are the same. So what I want to do is I want to change all my bases so that it's equal to the same thing. So I believe, and I know you're thinking about it as well, the base should be 2. Okay? Because 16 has a base that's 2 to the power of 4. Okay? 4 has a base of 2 to the power of 2. And 2 as a base is being raised to the first power. So now it's equivalent. I'm going to use the properties of exponents so I can simplify. So this becomes 2 to the power of 4x squared. This becomes 2 to the power of 2. And now this becomes 2 to the power of 1. Right, now that I have the same basis and it's simplified, now I can use the properties of exponents so I can simplify even further. So I know that if this is a division sign, that means we're following the quotient rule. And the quotient rule is for us to subtract the two exponents together. So I would like to subtract 4x squared minus 2. Was there an x over there? Yes, I'm sorry. My apologies. My mistake. 2 to the power of x. And it should be 2x right here. Okay, so let's continue. So we are going to subtract 4x squared minus 2x. Okay, so this is 2 to the power of 4x squared minus 2x. Okay, and that's equal to 2 to the power of 1. Right, so now that we have the same basis and it's a single exponential equation, we can set, wrong color, we can have this exponent equal to this exponent. Okay, so now we have to solve 4x squared minus 2x equals 1. Okay, and in this problem, this quadratic, I'm going to use the quadratic formula. Okay. First, I'm going to subtract 1 from both sides. So we have 4x squared, my fault, that's a different color. We have 4x squared minus 2x minus 1, and that's equal to 0. Okay? Okay, so now I'm going to use my quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. So this becomes x equals, let me scroll up a little bit. So we have negative b, which is negative 2 is b, so that's going to be negative 2, which is going to be a positive 2. Okay, so plus minus the square root of negative 2, all squared, minus 4 times negative 1. Okay, all over 2 times a, which is positive 4. Okay, so I'm going to do this first. I'm going to figure out what this is first, so I can simplify my square root if I need to. So that's negative 2 squared is 4, minus 4 times negative 1 is positive 16 because of that double negative right there. Okay, so 4 plus 16 is 20. So the number underneath the square root is 20, and I can simplify that further by using radical 4 and radical 5. So this is 2 radical 5. Okay, now I'm ready to further use my quadratic formula here. So that's 2 plus minus 2 radical 5. Again, I got that from this portion. Oops, sorry. Don't want to use text pen. I want to use highlighter. And so, excuse me. So we have to divide by 2 times 4, which is 8. Now we want to simplify. So that's x equals 1/4 plus minus, this is also 1/4, so that's the square root of 5 over 4. Or you can also say 1 plus minus square root of 5 over 4. Okay, so both of them are the same. Okay, I know we said that was the last example, but I do have another example. All right, my other example, and this is my last example of this video, is 27 is to the power of x is equal to 9 to the power of x minus 3. So because they don't have the same bases, you cannot say x is equal to x minus 3. Okay, we have to have the same exact bases. And we can't have the base of 9 because then what do you raise 9 to so that you could get 27? What you can do is you can change both of these bases so that the base is 3, all right? So you need to be a little bit skilled in recognizing what base you should use, all right? Sometimes it's obvious, and then sometimes you have to like stop and think about it. So 27 could be changed into 3 to the power of 3, all right, and then it has the power of x already. And then 9 can be changed into 3 to the power of 2, and it has this x minus 3. So it's important for you to know that this x minus 3 is one group, okay? So you will learn the importance in a bit. So I'm going to simplify this as 3 to the power of 3x, and I'm going to simplify this as 3 to the power of 2 times the group of x minus 3. And why that's important is because you have to use a distributive property. So technically this is 3 to the power of 3x, and technically this is 3 to the power of 2x minus 6, not just a 2x minus 3. Okay, so now that we have the same basis, we are going to, sorry about that, that's my alarm. So we're going to set my exponents equal to each other. Okay, so we have 3x is equal to 2x minus 6. Okay, and then we want to subtract 2x from both sides. And now this is a linear equation, so no need to use any type of formulas, right? All right, so this becomes 1x is equal to negative 6. And that is your final answer. 1x is equal to negative 6. And I thank you for watching this video. But the next video is going to have several different examples if you're still confused. And I will show you how to solve more of these exponential equations. Okay, so watch the next video. And I'll see you then. Thank you for watching.